Hello and welcome to the lesson Differentiating Exponentials, which is part of the Calculus unit in the Mathematical Methods course. First of all, let's define what exactly an exponential is. And in this case, when I say the word exponential, I'm referring to functions or expressions that take the form y is equal to e to the power of x. Or we'll see in a second, more complicated expressions that take the form y is equal to a times e to the power of b bracket x plus c, which is the most complicated form that an exponential can take. First of all, I'd like to point out this e is actually Euler's constant, and it's a very important number in mathematics. We'll see in a second it has one particular trait that makes it very useful, and it is a real number, so it has an actual value. It's around about equal to 2.7, and I put a special equality sign there to indicate that this is just an approximation. So let's have a look at why this Euler's constant is so special in mathematics. Basically, if we have y equals e to the x as our expression, dy dx is equal to e to the power of x. In this case, the function is the same as its derivative, which is very useful for a number of reasons. So down here I have the more complicated expression, y equals a times e to the power of b bracket x plus c. Let's look at how to derive that, and then we'll look at a few examples. So we have dy dx is equal to a times b times e to the power of, and the power of e does not change, e to the power of b x plus c. So we've brought the b down, but we have not changed the power. This distinguishes this kind of differentiation from the polynomial differentiation, because if we had, for example, y is equal to x squared, when I differentiate that expression, the power of x goes down. In this case, the power of e does not and never does change. So we'll have an example just to the right of that complicated expression. We'll say y is equal to 4 times e to the power of 5 x plus 1. dy dx is what we want to find. So first of all, I'll write down the values of the constants. A is equal to 4, b is equal to 5, c is equal to 1. dy dx is equal to a, which is 4, times b, which is 5, times e to the power of b, which is 5 bracket x plus 1. So as you can see, what e is being put to the power of has not changed. So that comes to 20 e to the power of 5 x plus 1. Let's have a look now at a more difficult example. Y is equal to root 2 times e to the power of 8, 3 take x. dy dx is equal to root 2 times negative 8 times e to the power of 8, 3 take away x. Now, the confusion that some students get here is, why was this negative 8 if we have positive 8 up here? And that's because we could rewrite this expression as y is equal to root 2 times e, 8 negative x plus 3, which is equal to root 2 e negative 8 x take away 3. So when we apply this formula over here, we always have to make sure that x is positive and it has a coefficient of positive 1 in front of it for that formula to work. If you'd like to see differentiation of any of the other expressions like e to the power of x, log ex, sin x, cos x, or tan x, please check out the other videos on differentiation.